The third assumption is about the independence of the residuals when the residuals are independent from each other. So there are some situations where we need to find out whether the error or residuals are independent or not. So the difference between observed and predicted values should be independent of each other. In survey data, this implies that the responses from different participants should not be correlated. It means uh, using a questionnaire, if two persons were surveyed using the same questionnaire, the responses of both persons should be independent from each other. They should not be correlated. If I have written or I have provided a digit 5 for a question and the other person has also provided the same, it means our responses are correlated with each other. So in other words, the error associated with one observation should not be systematically related to the error of other observation. So, error of different observation should not be correlated. The error of one observation should not be systematically related to the error of other observation. So, whenever the error of different observation or the residuals of different observations are correlated with each other, we may consider this situation as a violation of independence of error. But whenever the errors of different observations are independent, it means they are not correlated with each other. We may consider that the assumption of independence of error is not being violated; it is actually met. So you can see here on the right side a picture where each observation is basically independent from the other observations. They are not correlated. They are basically independent from each other. So it looks like a scatter diagram. So whenever we create a scatter diagram between our residual values and predicted values, you can see on the x-axis they have taken the standardized predicted values and they have taken the residual values on the y-axis. So whenever you are going to take your residuals values on y-axis and your actual dependent variable on the x-axis, and you will find a graph like this that each point is basically scattered from others. It means your errors are independent. Sir, please proceed the task at the end of the session. I can perform some network issue. All right. If anybody left behind during any process, you can see the recordings of today's session. I will upload tonight, and you will see if anything skipped during the process. We will find out how can it be applied. So don't worry about anything. If you miss anything, you can find the recordings. I will share the recordings. All right, how this process is applied, how we can check the independence of error or residues. You need to run the regression analysis. You go to analyze regression linear. You will select your dependent variable and your independent variable. You click OK to run the analysis. Then you go to the save residual button in the linear regression dialog box. Go to the save tab. Click both unstandardized and standardized residual, click continue and then click OK. This is the same procedure that we previously applied, but with some new additions. So what will we do next? Create a residual plot, go to the graph, legacy dialog box, and you need to create the scatter dot this time. Choose simple scattered and click define. Select your independent variable on the x-axis and residual on the y-axis. So previously we basically checked the independent variable on x-axis and dependent on the y-axis. But at this time, we can check the independent variable on x-axis while our residual on the y-axis. So this is basically the difference in the procedure, while the remaining procedure is the same. So click OK to generate the scatter plot. Examine the residual plot. Examine the scatter plot to check for any pattern or trend in the residual. If there is any pattern or trend in the residual, it means they are correlated. The errors are correlated. But if you didn't find any pattern or trend in the residual, it means that your errors are independent. So you need to find out a diagram like this. So if your scatter diagram does not show any pattern, whether increasing, whether decreasing, between your independent variable and your residual value as a dependent variable, and you find out the relationship, the scattered diagram like this, uh, you can conclude it as a independence of error. So we need to apply this procedure. How can we apply this procedure? First, you need to go to the analyze, then regression, then linear. In linear, what need to do is you need to put your dependent variable in the dependent list and your independent variable in the independent list or block one of one. Then you need to click the save button, and after clicking the save button, you will find uh, a box like this. We have applied this procedure previously, but with a different conception. You need to check the residual box unstandardized and standardized, and then you need to click the continue button, and then you will find uh, the previous step again, and you will need to click OK button. When you click the OK button, you will see that two columns will be will be generated here. If you have available these two columns as a part of your previous process, you don't need to generate them again. So if you have these two columns already, you don't need to generate them again. But if you do not have these two columns, you will need to generate these two columns again. So using the same procedure I have demonstrated right now. So what you need to do next, you go to the graph, then you select the legacy dialog box, then you select the scatter dot. You can click over here on the scatter dot, then you will find a box like this, from where you can select the simple scatter, and then you will click the define button, and then you will find a box like this. You need to put your standardized residual that you previously generated in y-axis, and then you need to put your independent variable in x-axis, and then you need to click the OK button. When you click the OK button, you will find uh, a scattered diagram like this. You can see that again there is no there is no any specific pattern over here. You cannot say that it is increasing or decreasing. It is basically showing that majority of your residual points are independent from each other. Some of them are correlated. You can see a small proportion over here. There may be some dependency. You can conclude over here some dependency. You can also conclude some dependency over here, but in majority of the parts, you can say that independence of residual is there. So how can we find out whether there is a pattern or not? So we need to put the reference line, and we will check that whenever we click the whenever we uh, whenever we click basically the fit line, it will become the horizontal line. It means there is no increasing or decreasing pattern. It is horizontal pattern. So we can say that it is basically uh, it is basically accepting the assumption of independence of residue. So if this fit line is starting from the downward and going to the upward, or it is starting from the upward and going to the downward, we would say that there is a linear relationship between residuals and independent variable, and in that case we would conclude that there is no independence of error uh, for our case. But uh, at present, we cannot conclude a linear relationship between our residual and independent variables. So we conclude here that our errors are independent. So this is how we can check the independence of error. What is the non-graphical method? There is a non-graphical method, but before doing it, we need to verify this procedure using our hands-on. Uh, so at first, we need to check whether we have these two columns or not. So we need to check from here, as I have deleted these two columns. So I need to generate these two columns again. So how can we generate it? Go to the analyze, go to the regression, then linear. You need to put your dependent variable in the dependent box. Uh, I have put the total marks. I need to put the final marks. Sorry, this is what. So you need to put your dependent variable in the dependent list, and you need to put your independent variable in the independent list. Then you need to go to the plot. No, this is not required. You need to go to the save button. Actually, you need to check the unstandardized and standardized from here, and then you need to click the continue button, and then you need to click the OK button, and you need to verify whether both the columns have been generated. And yes, you can see here our residues were generated. This is unstandardized residual, and this is standardized residual. So we have applied the first step. So what we need to do as a second step, when we have generated it, what we will do as a second step, in the second step, when we have generated our standardized residual, we need to go to the graph, legacy dialog box, and scatter dot. So how we can do it? We go to the graph, we go to the legacy dialog box, we need to click on scatter dots, we need to select simple scatter, we need to click on define button, we need to put here in y-axis the standardized residual. You just need to put over here, and then you need to put your independent variable in x-axis. So our independent variable is GPA. So you need to put it over here, and you need to click OK button, and you will find a graph like this. So this is basically the graph. And in order to find out whether there is a linear relationship between your GPA and your standardized residual, you need to double click over here. You need to click on the reference line, and then you need to click on your fit line. So when you click on the fit line, you can see that it becomes horizontal. It is not a straight line. It is not starting from the downward and going upward. It is not starting from the upward and going downward. In fact, it is basically the horizontal line. So it is an indication that your errors are independent. So we can conclude here that our assumption is not violated. The data has meet the assumptions, and we can conclude here that our error is independent. So this assumption is met, and then we can go for non-graphical method. So how can we apply the non-graphical method? First, we need to understand the procedure, that how can we apply the non-graphical method. So here is the Durbin-Watson test. It is basically the optional test when we need to check the independence of our error using non-graphical method. We have the Durbin-Watson test. So how can we find out the Durbin-Watson, and what is the decision criteria? If you want a formal statistical test for autocorrelation, you can use the Durbin-Watson test. So it is the same test which you can use for auto correlation, and you can use the same test for independence of errors. So you need to go to the analyze, regression, linear, put your DV and IV in the relevant boxes and click on the statistic button. Check the Durbin-Watson statistic in the residual box, click continue and click OK. That is very simple procedure. First you need to go to analyze, then you need to go to the regression, then you need to click on the linear, you need to put your DV and IV in the relevant boxes, and you need to click statistic button on the right side. And from there you need to check the Durbin-Watson statistic in the residual one, and then you need to click continue and click OK. So here is the screenshot of Durbin-Watson procedure. You need to go to analyze button, you need to go regression, then linear, and what you will find the next, you will find a table like you will find a box like this. uh, you need to put your dependent variable in the dependent list, you need to put your independent variable in the independent list, then you need to click on the statistic button, which is the first button on the right side. After clicking it, you will find another box like this. From here, you need to check Durbin-Watson statistics. This one from the residual part. So you need to check Durbin-Watson, and then you need to click on continue button, and it will provide you a table like this. In a model summary table, you will find a value of Durbin-Watson. So how can we interpret this value? A value close to 2 indicates that residual are independent. So if the value is close to 2, sometimes it is equal to 2 or sometimes it is close to 2. So when your value is near to 2, we can consider it that our residual are independent. But if the value is less than 1 or greater than 3, if this Durbin-Watson value is less than 1 or greater than 3, it indicates that residual are not independent. So it is very simple procedure. So we can apply it by our own self. So what we need to do is we need to go, we simply go to the analyze, we need to go to the regression, linear. We have our dependent variable over here, our independent variable over here. One thing I would like to let you know that we have already created residuals over here, and each time whenever we run a fresh regression, it will generate it again and again, and it will increase the column in your data view. So we need to uncheck from this procedure. So we need to go to the save button, and we need to uncheck residual spending. Click continue. The thing that we want for Durbin-Watson, we need to go to the statistic, and then we need to check the Durbin-Watson statistic. Then we need to click on the continue, click OK, and uh, you will find the regression tables like this. You need to check only the model summary table. Here you can see the model summary, and you will find the Durbin-Watson value, and it is close to 2. As this value is close to 2 or near to 2, we can say that our errors or our residuals are independent. So this is the third assumptions that we have tested, and I think we should conclude our session up till here, because there are three more assumptions that would require at least two more hours. So we should continue from assumption number four from tomorrow, and we will also discuss basically the regression cases tomorrow along with the remaining three assumptions. So, what is your suggestion? Should we continue the remaining assumptions from tomorrow, because it will take 2 hours more to complete the procedure? What is your suggestion? Should we take the break and we should continue from tomorrow for the assumption number 4, 5, and 6? Please let me know.